What's up guys, this is LeetCode 819 most common word. Given a paragraph and a list of banned words, return the most frequent word that is not in the list of banned words. It is guaranteed there is at least one word that isn't banned, and that the answer is unique. Words in the list of banned words are given in lowercase and free of punctuation. Words in the paragraph are not case sensitive. The answer is in lowercase. So the first example, we have a paragraph with Bob hit a ball. The hit ball flew far after it was hit. Banned word is hit, output ball. It's ball because hit occurs 3 times, but it is banned word. Balls occurs twice, and no other word does. Yes, ball here and ball here, and we have to ignore cases. So we have to ignore everything but letters, and we also have to transform this paragraph into lowercase. Yes, so I think the solution will be, let me see. Yes, we can first remove everything but letters. We can use replace for this. We can also make this paragraph lowercase with lowercase function. And also, as we have to check banned words every time we find a word, it will be nice to have this check in a constant way. So I think we can put everything from banned words into a hash set. And yes, I think that's it. And after that, as we have to count the number of words, I already said this in another video, every time we have to count something, it is good to do this in a hash map, because in a hash map we can find the key in a constant time and we just have to increment its value. So yes, I think that's pretty much the solution. Let's try to write some code. As I always say, let's check if the input is valid, even if the exercise is not asking. It's always good to check. So if paragraph.length is equals to 0, return an empty string. And as I said, we're gonna have to check for every word in this paragraph. We will have to check if it is in the list of the banned words. So it is good if this check occurs in a constant time. And for this to happen, we will put every word in the banned word in a hash set. We can do this by declaring a banned word, which will be a hash set of string, and put all the banned words here. Okay, so after doing that, I think we can remove everything but the letters from the paragraph, and we can do that by using regex.replace. And let me see, I think we can also use the same variable. Yeah, I think we can do this in the paragraph. So paragraph is equals to regex.replace. We will use the original paragraph, and also we can remove using regex by doing, I don't want to consider anything but letters. So yes, actually I want to consider just letters, because in this line I will remove everything but letters. So we can do that by using these regex here. And let me see, I think we can also do the to lower here. And now we have a paragraph with only letters, and all the letters is in lowercase. Yeah. As I said before, we will also have to count every word in this paragraph. And as I said in another video, every time we need to count something, it is always good to do using a hash map or an array. In this case, we use a hash map because we need the key and its value. So we can have the word counter is equals to new dictionary of string and int. Okay, so now by doing that, we can start to iterate through the paragraph, all the words in the paragraph. We can do that by doing a for it of word in the paragraph, split it into spaces. We can now first check if the current word it is not in the banned words, because if it is, we can go to the next one. Like if banned words contain the current word, we can just continue to the next one. After that, we can check if the word counter hash map contains a key of word. I actually want to check if it does not contains, because if it is not contains, I will create add word with the count 0, because I will now increment here. Like this. So checking if it is in the banned words, checking if the current word it is not in the hash map, and after that I will increment the counter of this word. Okay, so now we have a list, actually a dictionary with all the words and the times that it appears in this paragraph. Now we have to iterate through this hash map and checking if the current word is the word that most appear. So we can do that by creating a result variable and iterating through the hash map. So we can iterate through the hash map by doing item in word counter. Let me see. Okay, so as we are starting with the empty result, we have to check here if result is empty, because this is the first case, or if the current item of the dictionary, like the value, is greater than the word that the result variable is using right now. So if this is true, I have to replace the current result with the current key. So result is equals to, this is actually item, not word counter. Word counter is the dictionary itself. So this is item, and here is also item. Okay, when I get out of this iteration, we can just return result. Let me see if we have any typos here. Rejects. There is an important thing here, because we are using regex and we have to import the namespace that propose us to use these regex. So regex.replace, it is in the system.text.regular expressions. And by importing this namespace, we can use the regex. So yes, let's try to run the code. So line 9, an object reference is required for a non-static regex.replace. Okay, so there is only two parameters here. We are passing the current string, we are passing the regex, but we also need to pass what we want to replace. So I want to get everything but letters and transform it in a blank space. Whoops. Yes, like this. And also line 15, what we have in the line 15, when words contains words, so when word does not exist, so when words, plural, like this. Try to run again. Yeah, that's it. Let's try to hit submit. Yeah, so that's it, guys. The time complexity for this solution is, let's check here. We are iterating through paragraph and then word. So yeah, so I think the time complexity here is big O of P plus B, where P is the length of paragraph and the B is the length of n words. And also we are using extra space here. We are allocating space for ben words and for the word counter. So yeah, so also the space complexity here is P plus B, and the same, P is the length of paragraph and B is the length of ben words. Okay, so thanks for watching.